Alright, today we're going to go over how to design a pit tank using engineering field tools, EFT. You go to Start. If you don't have EFT, your taskbar, just search it. It'll come up, click it, and this will open. I already have it open. I'm going to go File, New Survey Design. Name the name of your customer. I'm just going to say his name is Jerry. Next, Jerry Project. Next, Jerry Survey. Finish. It'll read in the design file, and we can start. So you can see what we did was just now it's kind of redundant. It puts everything that you just entered into the name under report title block information. So you can just change this later. Put who was designed by, who was drawn by, what the practice name was. I think this is 372 Pond. The location of the pond. After you enter all this, you'll have a report that you can use in basically a whole design. So we're going to bring in our survey. You can bring in a CSV, text file. There's a whole bunch of other ones. We'll just name it Jerry Survey. Click OK. We have to bring in our survey, so we're going to click Import Data, browse for where it's at. I'll go to, I'm going to use this survey. This is from a different project, but I'm going to use it. Open. It reads in all the survey points. Click Finish. And then everything, all the points will come in. You just accept edit. And it didn't come up, the topographic survey, so you have to click full extent, and there's all the points. So there's one point in particular that I don't want it to capture, and it's this 1264 F1 point. So I'm going to go click the survey, and I'm going to point number 1264 I'm going to make not tenable. So click the survey, open it, and point 1264, I'm going to find it, and I don't want it tenable. You can make it not visible and not tenable, but I don't want it tenable. So I'll click that, accept edit, and my survey now, the survey, topographic survey looks like this. So let's go to zoom extents, there it is. I want to zoom in just on this is a field I surveyed a while back. And I'm going to say that I want to put a pit tank right in the middle of this field. So now we're going to design our pit tank. We're going to assume for this that we're designing a livestock pit tank. And on livestock pit tanks, the side slopes can't be greater than 2:1 as per standard and specs. And one of the side slopes must be 4:1. So now we're going to go design our pit tank. So under structures, you can click new. I'm going to name it Jerry structure. Click OK. And then I want the center, or this point right here of my pit tank, to be right where my cursor is. So if you see, I'm hovering over this point, and the corresponding X and Y comes up down here. So let me see if I can get a screenshot of that. Well, anyways, if you look at my cursor and then you look down here, you'll see that the X and the Y will change. And so I'm looking to find this point right here. So that point right there, if I leave my cursor there, I'm just going to write it down on a piece of paper. In the X, my easting is 15408.99, and my Y in the northering is 214036.68. So I want my middle of my pond to be right at that point. So, and then I want my pond, the elevation at that point is 7865.81. If I want my pond to be minimum of 12 feet deep, then I'm going to add 12 feet to 7860, or subtract 12 feet from 7865.81, and I'll end up with 7853.81. So now I'm going to go to my center, and I'm going to put these points on there. So I want 154,408.99. I want my Y to be 214,036.68. I want my bottom to be 7853.81. Basically, I chose 12 feet because the minimum that we're supposed to go when we design a pond is 12 feet. I'm not going to do anything in my rotation azimuth. We're going to design it and see what happens. There's a vertex point that lies outside the surveyed ground. So, and then on my bottoms, I want a minimum. Okay, sorry, I'm going a little bit too far. So I chose my X and Y and Z at this point here, where my cursor's at. I got the X, Y, and Z from down here. Now on the bottom width and the bottom length, as per the standard, we're supposed to have a minimum of 200 square feet. So I'm just going to make it 10 by 20. And then on a livestock pond, we want at least one 4-to-1 end slope. So I don't want to use equal side slopes. I'm going to have this side be 4-to-1. I'm going to have this side be 3-to-1. All the other ones be 3-to-1 actually. And then we'll design survey point. I think what's happening is it's too big of a pond, so we're gonna have to make it smaller. Okay, so when I click design, I was getting a message saying Vertex Point lies outside survey ground. So when this happens, you want to look and see at your look at your X and Y points and make sure that you have them correct. And I found out that I was missing a 0 and a 9. And so now when I click design, a pond shows up. So once again, if you miss one number, it can screw up your design. So it's basically saying that I have a point that doesn't exist on my tin. So let's just a lesson learned on my part. So we're going to put a 0 and a 9 that I was missing. Design, and finally there's the pit tank. So the pit tank once again has a 10 by 20 bottom, one 4-to-1 in slope, and the rest of them are 3-to-1 side slopes. So you can see that as is, if I wanted to put a pond on this surface, that it would not fit. And the reason is, you can see this corner of the pond, this corner of the pond, and then the pond corner that should be over here somewhere. It's off my field. So we know that with those dimensions it won't work. There's a possibility if we cant it clockwise, it would work. So we're going to play with that now. If you can do that using the rotation azimuth, we're going to cant it 45. Just try it. Click design. And let's zoom in. Pan. So there's my point, my survey. It's kind of hard to see. Let's get rid of some stuff so you can see it better. Well, let's get the border on. So there's my border and the contours, major and minor. So my corners are still kind of outside the my survey. So what I can do is, because I can't get the depth I need there, I can reduce the depth let's just reduce it by a foot. So instead of 7853.8, we're going to go 7854.8. And then we're going to design it. And my pond came in a little bit. So we still don't want to be outside of the field. We've got to make this pond fit. So we're going to go to 7855.8. And it looks better. Let's go to 7856.8. And that's pretty much in there. The other option would be we could reduce the slopes. Instead of having 3-to-1s on the sides, we could have all 2-to-1s and 1 4-to-1. So let's see what happens with that. Let's leave the original elevation of 7853.81. Design it. The corners are outside a little bit. And it even tells you right here, structure extends beyond surveyed ground. Calculated volumes are incomplete. So let's just do what we did earlier. 4.8 design. Structure extends beyond. So let's see, I didn't notice earlier. Let's go to 5.8 design. The structure still extends too far beyond. Let's go to 6.8. We're just making it the pond shallower and shallower. It still says the structure extends beyond the survey ground. So let's go out another foot, 7.8. And finally, we're within it. So let's just stop there. The pond is now within the survey footprint. We rotated it 45 degrees. We did 3-to-1 side slope, 3-to-1 side slopes, and 1 4-to-1 side slope. A 10 by 20 bottom, so as to get a minimum of a 200 square foot bottom. And then we had to basically go from 7853.8 to 7857.8. So we reduced the depth of the pond by 4 feet so as to get the pond footprint within the surveyed area. And when we click design, it's telling us that we have a total cut volume of 581.2 cubic yards, a storage volume of 0.28, and a storage depth of 7.4. So alternatively, let's just say that we kept the bottom at the original elevation, the 12 foot deep minimum that we're supposed to design for. Click design. Like I said, the structure extends behind it. Let's just change the side slopes from 3-to-1 to 2-to-1 and see if that does anything. And keep the 4-to-1 design. So that would be an alternate. The maximum slope you can have on a pond is 2-to-1. When we change our side slopes that were 3-to-1s to 2-to-1s, our footprint stayed within the surveyed area, and it tells us that we have a cut volume of 1,026.8 cubic yards, storage volume of 0.53, and a storage depth of 11.39. So let's just stay with this design. So we're done with that. Now we're going to accept the edit. And then finally we're going to go to run a report, file, print reports. It'll always prompt you to save before you print the report, so let's do that. Click OK. Tenable point outside border, name 1201, ID 3. Okay. We're going to check project points report, survey data, click finish, survey data report, structure report, next. Click design, stakeout report, finish, click OK. It'll take a little while to put the report together, but essentially after you got this done, the design portion of the pit tank is, as far as the layout and the associated cuts and fills, or cuts, will be given. You will have, prior to doing this pit tank design, done the Chapter 2 hydrology to see if indeed you even get enough water to fill your tank. It just finished the report. On the report, it shows you all the points from your survey, and then the meats and potatoes of the report comes down to the last 2 pages. It tells you the center of where your pond's going to be relative to the x and y coordinates. It tells you what the bottom elevation is. That's what you specified. The bottom width is 10, bottom length is 20, rotation azimuth 45. There's your cuts. It tells you the slopes. And then what's most helpful about this is the structure stakeout. So it has acronyms that basically describe what is what. So bottom width is 10, there's BW. Bottom length is 20, there's bottom length. And then the side slope, SS1 is 4 to 1, SS2 2 to 1, 2 to 1, so on and so forth. When you're going to stake this out, you can see that the field we're designing on is pretty much flat, therefore all the cuts are within 12, we're pretty close to each other. So the bottom B1, this point right here, is going to be a cut of exactly 12. Bottom 2, you're going to have a 12.1 cut. And as far as your I1, I2, I4, and I3, those are where your pond corners daylight. And you can see they daylight at 0, meaning they're right at the top of the ground. So that's the whole report. If you have any questions on how to design a pit tank, that's the quick and dirty. Like I said, before you even size your pond, you will have done your Chapter 2 hydrology to see how much water your pond will hold based off the drainage. If the drainage even gives you enough water to fill your pond, you will have done a soils report to check the soils to see if your pond will even hold water. So there's a lot that goes on behind the scenes before you design a pit tank. But this is how you would, after you've done all that background work, this is how you would design a pond using EFT. Very easy. If you have any questions, let me know. And once again, if you need to modify what your surface looks like here, you have all the layers available to you under this tab here. So sometimes there's just too much going on and you have to turn things off. So I usually just get rid of everything except for the contours, get rid of the triangles, and I kind of like leaving that. One thing that I do, if you want to, because the report does not give you a topographic image of your survey, I will simply just go and do a snip, click snip. I will snip the extents of the survey. I will save it. I'll say survey snip. And then I will exit out. I'll go into Word. I'll create a new blank document. The page layout, I will make the orientation to be landscape, the margins to be 0.5, the size to be 11 by 17. And then I will insert the snip. And actually, let me change the page layout so that the orientation is portrait. And there is my, I can print this out. There's a survey design. And you probably want to have more points than just major contours and the minor contours. So you could put the point labels and how they how they relate to your survey, or how your points relate to the pond, and then just snip this. Once again, snip, save. I'll override this snip, and then I will put it. It saves it in the memory. Right click, paste, and then there's my topographic survey. If you have any questions, just shoot me an email or call me.